What's up, amigos? So we had a request from one of you amigos, Marco Vukadin, to test the aerodynamics of an iron. And being the lambs we are, here we are. Here is an iron, and we have a Y plane going through the middle of it. And we can see a couple of things. First of all, the wake is fairly well behaved for how bluff you'd think the iron is. The front part is quite nice, but the handle is just popping out, so you think that it's quite a bluff body. But it's not too bad. The drag is actually 0.26, which is actually better than a lot of cars. So maybe we should be driving around in iron-shaped cars instead of regular cars. And this Y plane shows a pretty nice angle. It shows that, okay, there is a fairly decent wake, but it behaves itself quite nicely. It's only about one iron downstream where we start to have the wake dying out quite a lot, and you have a fairly nice flow. So that's why this iron has quite a low drag coefficient. Interestingly, it also has a negative lift coefficient, so it actually produces downforce. It's minus 0.041, which is actually also better than most cars as well. Most cars don't produce such a nice downforce, and that's potentially a problem for handling. So irons might be the way of the future. So this Z plane goes halfway through the iron, and as you'd expect, there is a periodic shedding of the flow from one side to the other because it is still a fairly bluff body at the back. The front, even though it is quite nicely streamlined, the back you could make better by making it sharper so the flow can stay attached longer instead of just separating at that trailing edge. So this handle I'm quite interested in. I have a Y plane going through it, and for how small it is, it produces such a big wake. So this is probably one of the biggest culprits in terms of producing drag. If you were to remove this handle, the drag of the iron could drop significantly. In fact, it would probably go down below 0.2, I would imagine. So this handle could be more streamlined or completely removed. So these X planes are showing the wake downstream, and it's kind of interesting because, as I mentioned, this iron is kind of halfway between a streamlined body and a bluff body, and this kind of indicates that exact thing in these planes, where the first three planes are quite steady, and then it's only until the last plane really where you get a lot of unsteadiness, which is indicative of a bluff body. So there's half of it which is kind of streamlined, half of it which is bluff. That's quite interesting. So if you want to get better at CFD and theory yourself, check out our courses in the link in the description. And if you want to make your experiments 2 to 4% more accurate, check out Atmosphere Hawk, link in the description. And I'll see you next simulation. Peace out, amigos.